Right, we're looking at three sequences and we're asked to give the nth term or the general formula for these sequences. So the first thing I'm going to do is I'm going to look at the differences up here. So this one's plus 5, plus 5, plus 5. Now, we could easily generate the next few terms, couldn't we? Because it's just add 5, but we're not asked to do that. What else do we know goes up in fives? And that's going to be the 5 times table. So if I write the 5 times table here, 5, 10, 15, 20, okay, can we compare our sequence to the 5 times table? And the difference between them actually is going to be take away 1. So we're taking away 1 each time, take away 1, take away 1, take away 1, which would then mean that our nth term is 5n, the 5 times table, take away 1. Same sort of thing here, but this time slightly different because we're going down this time. -3, -3, and -3. Now, we're going to compare our sequence to the -3 times table. Now, the -3 times table is exactly like the 3 times table. It just has a negative sign in front of each of its terms. So, there we go. Can we now compare our -3 times table with our sequence? And if you look carefully, you can use a number line for this. You need to add 23. Okay, and we're always adding 23, adding 23, adding 23. So our nth term, and if we want to put it in the same sort of order, would be -3n, because it's the -3 times table, plus 23. But if you want to make it look a bit neater, you could just do that. Oh, not 2, 3n. Okay, and there we go. Both of those would be absolutely right. In an exam, you get the marks for those. Now, down the bottom here, we've got a fraction. Don't be put off by fractions. They look a bit nasty. It's not too bad. Now, we're going to actually look at the two sequences separately. So up the top, we've got 1, 2, 3, and 4. Difference being +1 each time, +1. Okay, so we're going to compare those to the 1 times table. So 1, 2, oh, hang on, it's the same. So that's fine. So that one is just n. Okay, and then the next one, we got 4, 5, 6, and 7. Once again, going up in ones. +1, +1, and +1. Okay, so how can we compare these? There's the 1 times table again. 1, 2, 3, 4. What are we adding each time? Well, we're adding 3 each time. So therefore, this is n plus 3. And our nth term, and I'll write it down here. It's the only place I've got a bit of space left. N goes on the top, n plus 3 down the bottom. Okay, fractions, just look at them separately. Don't let them scare you off.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.